let's try to solve this question over here. When viewing a piece of art that is behind glass, one often is affected by the light that is reflected off the front of the glass, called glare, which make it difficult to see the art clearly. So this is a typical scenario that we can encounter if you visit an art gallery which consists of expensive pieces of art. So the art is usually, they need to protect the art, so what they will do, they will lay it with a piece of glass in front of the art. But the problem is when you have this kind of glasses, right, when you have spotlight shining onto the art, let's say you place a spotlight and you shine light on the art in order to make it clearer to be seen, the problem is the spotlight itself will get reflected off the glass, and at the end what the viewer of the art gallery, what they will see is not the art, instead they will be seeing the reflection of the spotlight itself. Okay, so that reflection of the spotlight is what we call as glare, and it makes it difficult to see the art clearly. Okay, so one solution is to coat the outer surface of the glass with a film to cancel part of the glare. So you have your glasses, right? So what they suggest you to do is you apply something on the outer surface of the glass. So you apply something in order to create a thin film in front of it. So by having this thin film in front of it, what happens is the reflection will cancel out part of the glare. So it means that even though you have your spotlight arriving onto the glass, the reflected ray over here, the ray reflected here, we have some part of it being cancelled out. Okay, so not a very strong reflection compared to earlier. The reflection will get weaker, so we expect that the reflection of the spotlight to be weaker, so we can see more of the art, maybe. Okay, that's the idea that they're trying to say here. So if the glass has a refractive index of 1.62, and you use titanium dioxide, okay, which has an index of refraction of 2.62 as a coating, what is the minimum film thickness that will cancel light off wavelength 505 nanometer? Okay, so let's try to figure out the setup that we have over here. We can probably say that for this situation, question A, what you have here is it's very important that we figure out the 3 layers. So our thin film here, it's the coat that we apply, which is titanium dioxide. Okay, so this titanium dioxide will be the coating that we apply, and this is where we find our thin film. Okay, so above our thin film is where you have air, because that's where the spotlight's light comes from. Then you incident onto the film, and below the film, we know that this film is being applied on the glass, so the film the material below it, or the medium below it, will be glass. There's art also, but art is below the glass, so that's not of our importance. Okay, so you have air, titanium dioxide, and glass. Let's label the index of refraction for all of this value. Air is 1.00, titanium dioxide is 2.62, and glass is 1.62. Why do we need to label all of these mediums correctly? Because it allows us to determine how many phase change occur. So it's very important that we determine how many phase change occur, because by knowing how many phase change there are, we know whether we need to flip our equation for constructive interference and destructive interference. Okay, so let's try to look at it. So for the first boundary over here between air and titanium dioxide, air is having a smaller index of refraction, titanium dioxide is having a larger index of refraction. So if you go from a smaller index of refraction to a larger index of refraction, there will be a phase change. So here you will find phase change happening if you go from low to high or small to large index of refraction. For the second boundary over here, you are going from 2.62 index of refraction to 1.62. So you're going from high to low, or you go from large to small. If you go from large to small, there is no phase change. So for the second boundary here, there is no phase change. Okay, so for this situation, how many phase change do we find? One single phase change only. So because it's one single phase change only, you know that the equation for constructive and destructive interference, we need to flip once. Okay, so because if you flip once and now you want the destructive interference equation, why you want the destructive interference equation is because they want to cancel out part of the glare. If you want to cancel out part of the glare, cancel means by you want it to disappear, right? If you want it to disappear, the light wave, the two light wave should interfere destructively, so they cancel each other out, so they disappear from the reflection. So right now you're asking for destructive interference equation, but with a one phase change. So initially constructive equation has m lambda, whereas destructive equation has m plus half lambda. But now because there's a one phase change over here, what happens is you will swap the equation. So now for constructive equation, it will be m plus half lambda, but for destructive equation, it will be m lambda. So now we have successfully picked our equation. Our equation will be 2nt is equals to m lambda. Okay, so if you proceed to do a substitution, n here will be the n of the thin film. So thin film is 2.62 for titanium dioxide. And they want to know the minimum film thickness. So you should probably label this as T minimum. So if you want the minimum film thickness, what we need to do is you want to minimize the value of m over here. Okay, because if you minimize the right hand side, the left hand side will be minimized as well. So you get the minimum thickness. Well, what's the minimum m you can substitute? You are not supposed to substitute 0, because if you substitute 0, your thickness will be equal to 0, which defeats the purpose of this question, because you're saying that there's no thin film at all. So if they're asking about minimum film thickness, you should expect the thickness to be a certain value which is not 0. The smallest value that is non-zero. So the smallest value that is non-zero, you can get it by substituting m is equals to 1. Okay, not 0 but 1. So your wavelength will be how much? 505 nanometer. 505 times 10 to the power negative 9. So from here you can find your minimum thickness here to be equals to 0.964 times 10 to the power negative 7 meter, which if you want to convert into nanometer, it will be 96.4 nanometer. Okay, I'm not sure what particular light is this. I think it's near ultraviolet, maybe very near ultraviolet, very near the purple range, somewhere around there. I'm not really sure, but this is the light that will get cancelled out. Okay, this is the minimum film thickness. What am I saying? This is the minimum film thickness that you require to coat onto the glass in order to cancel out light wave of 505 nanometer. 505 nanometer is about, where is it? It's about greenish blue, somewhere around there. Okay, so if you want to cancel out the green light, maybe green light, somewhere around there, I'm not so sure. Okay, but if you want to cancel out this particular wavelength, the minimum thickness of coating that you need to apply is 96.4 nanometer. Okay, so ignore what I said earlier. This is not the wavelength, this is the minimum thickness of coating that you need to apply. Okay, so now what do they say in question B? Question B asks, if this coating is too thin to stand up to wear, it means by if we apply it according to this thickness, what happens is it can easily wear off. Okay, so maybe some sunlight shining on it, or some dust, or some humid air, it will cause that film to what happened to the film? The film will get destroyed maybe, or the film will not be of good quality. Okay, it will wear off maybe if the coating is too thin for this thickness over here. So what do they ask for? They ask what other thickness would also work. So they want other thickness which is not this value over here, because this value over here is too thin, then it cannot stand up to wear. Okay, it cannot withstand the heat, or it cannot withstand the humidity, something like that. Okay, so they want you to find only the three thinnest one. So but they don't want the thinnest one, they want the next three thinnest one. So next three thinnest one will be m is equal to 2, m is equal to 3, and m is equal to 4 lah. So if you substitute m is equal to 2, m is equal to 3, m is equal to 4, you are able to get the second thinness, the third thinness, and the fourth thinness. And that's what the question asks for. Okay, so I'm going to okay, I'm just substituting one by one. Okay, if 2n t2, that will be equals to 2 lambda. So this will be 2.62. T2 is equals to 2.505 nanometer. Okay, so that allows you to find T2, and T2 will be 193 nanometer. Okay, you can do the same thing for T3 as well. T3 will be substituting m is equals to 3. So this will be 2 times 2.62 times T3 So this will be 3 times 505 nanometer. Okay, so the result of a calculation for T3 will equals to 289 nanometer. And then if you continue to find T4 as well, 2n T4 is equal to 4 lambda, so 2 times 2.62 times T4 is equals to 4 times 505 nanometer. So T4 here will be equals to 385 nanometer. Okay, so we have successfully determined the second thickness, the third thickness, and the fourth thickness possible thickness in order for us to cancel out 505 nanometer. Okay, if you cancel 505 nanometer, it doesn't mean by the whole spotlight reflection disappear. You only cancel part of it. Maybe if the spotlight consists of a rainbow spectrum from red to purple, you maybe cancel the green, maybe. So the reflection will be sort of reddish, maybe. If you cancel the green, then it might look a bit reddish because that's what's left of the reflection. You cancel the green, so you're left with around the red or the orange or the yellow, those kind of wavelength. So that is what you see from a reflection, and it's definitely less intense from before because some part is cancelled already, right? So the reflection will be less intense than the incident ray. So if the reflection is softer, then probably you are able to see the art more clearly. Okay, so that's it for this question. Thank you very much.